Setting up and managing your own server is a very time-consuming process. There's a lot to learn and a lot to figure out. And there have been some attempts at solutions to kind of streamline this process. And so in episode 730 of Syntax, Scott and Wes talk about some of these PaaS, or Platform as a Service, solutions that you can host on your own server and get a Netlify or Heroku or Vercel-like experience. Now, one of the tools they talk about, and one of the things that people have been asking about in the YouTube comments and on Twitter, is Coolify. So I have spent the last 2 weeks learning everything I can about Coolify, and in this video, I'm going to show you how to set it up. But we're not just going to stop there. I'm going to show you how to debug Coolify when things go wrong. I'll show you how to deploy apps that are based on Docker and Docker Compose files, and I'll also show you how to set up HTTPS and www redirects for all of your wildcard domains that are running on your Coolify instance. So let's get into it. I'm CJ. Welcome to Syntax. Once you have Coolify up and running on your server, you'll get a nice little dashboard that looks like this. It has a place where you can look at all your projects, and for any given project, you can manage all of its resources. So a resource is something like a database running in a Docker container, or an app running in a container, or a service stack, which would be like a Docker Compose with multiple services. And you can also add new resources. And so when you add a resource, you can source it from a public repo, a private repo. You can also just specify a Dockerfile or a Docker Compose file, or the name of an image on some Docker registry. They also have one-click deploy for some pretty commonly used databases, and they also have one-click deploys for some pretty commonly used service stacks. Now, if you hook this up to a private Git repo, you can actually set up a GitHub app, and this will configure everything so that you have webhooks. So anytime there's a change to the code for that app, it'll automatically alert to Coolify, and Coolify will rebuild and redeploy your app. From there, within your applications, you can manage these resources. You have lots of settings that you can configure, including looking at the container logs. And from there, you're good to go. So anytime you need to manage things, you'll just log into the Coolify dashboard. You can see status of stuff. You can start things up, stop things, add new resources, and stuff like that. Now, when you install Coolify on your server, you're going to need to make sure that it meets the minimum requirements. Now, if you look in their docs, they say that Coolify needs 2 CPUs and 2 gigs of RAM and 30 gigabytes of storage. That's for Coolify alone. So just to run the Coolify dashboard and everything that it needs, those are the minimum specs. So anything you want to run on top of that is going to need more than just 2 CPUs and 2 gigs of RAM. You can see an example description down here of a server with 4 CPUs and 8 gigs of RAM and all the services that it's running. And what they're saying is they're never at more than 30 or 40% usage with all of these apps and these specs. But your mileage may vary. It's going to depend on the kind of apps that you're running, the amount of users that you have. But at a minimum, you need this just to run Coolify, and anything on top of that, any other services you're going to want to be running, you'll need to make sure that you have more resources. Now let's see an example of spinning up a server on Hetzner and some of the options that they provide. So when I add a server here, I can choose a location. I'm going to go to Hillsboro, Oregon, because that's closest to me. We're going to do Ubuntu 22.04, and we're going to choose the shared CPU. Now you can see the cheapest option they have is about $4 a month. It's 2 CPUs and 2 gigs of RAM. That is only enough to run Coolify itself. If you want to run another database or anything else, you're going to want to make sure that you have more specs than that. So at least the next tier. Now, I'm going to choose this tier here that has 4 CPUs and 8 gigs of RAM. It's about $14 a month, but that's on par with the service that they're describing here with all those services running. So in all of my tests, this seemed to do just fine. It didn't get bogged down when I was doing Docker builds or anything like that. It's a pretty decent machine. Now let's set everything else up. You're going to want to set up an SSH key. If you don't set up an SSH key, they're going to email you a root password, but you don't want that. So definitely set up an SSH key. In the first video in my self-host series, I actually show you how to set up SSH keys. So I'll link that here. You can go set those up if you haven't yet, but you're going to want to just click here and then add your SSH key. And this is going to allow you to log in as the root user without specifying a password. It's just going to use your SSH key. Now from there, we're going to skip firewall setup for now, but I will show you how we set up the firewall in a little bit. And we are actually going to do this cloud config. So in that first video in the self-host series, I show you how to lock down SSH, how to create a non-root user, all that stuff. I have a cloud config here that does all of that. And I'll walk you through what this is doing. And I'll also link you to some docs on how you can create your own. But if you're also curious about what we're doing here, definitely check out that first video in the series where we kind of walk through this stuff manually. But with this cloud config, it's going to create a user called CJ, set it up with that same SSH key so I can log in with that user. It's going to add them to the sudo group and set bash as the default shell. And it's going to set a default password that has to be changed the first time this user logs in. Now, the commands we have running here are setting up our preferred SSH settings. Now, if you watched the first video in the series, I talked about how you actually want to disable root login to lock down your server. In this case, we can't because Coolify needs to be able to remote into the server as the root user. But what we will do is we'll disable password login as the root user. So we're changing the permit root login setting to be without password. And that means a root user can log in over SSH, but they have to use an SSH key. And that's going to use the SSH key that we set up in the Hetzner settings there. We're also enabling public key authentication, and we are disabling password authentication. So no one will be able to log on over SSH with a password. And this is to prevent those brute force attacks of bots trying to automatically log in as users by trying a bunch of different passwords. That'll restart the SSH service. And then we have some commands here that will update all of the package lists and install all of the latest packages in an unattended way and then reboot the server. So this one config is all I need to do all the things that I covered in that first video in the self-host series. So what you can do is you can grab this, paste it in over here, and that's going to run it on the server whenever it spins it up. Now, if you want to learn more about Cloud Init, you can check out their docs here. There's so many more settings that you can specify to pre-configure a server, but this is all we'll need here. And I'm going to give it a name of Coolify. So let's create it. And then once it's spun up, we'll SSH in. So the server's up and running. I also waited a couple of minutes to make sure that the updates finish running. And now I'm going to copy that IP address and SSH in. So we'll do SSH root at that IP address. Now, this will use my public key that I set up earlier. If you didn't set up a key, then you're going to have to type in your password. The first time you connect, you will see this message. Just type yes, and you should never see this message again. If you do, you're the victim of a man-in-the-middle attack, so don't connect to that server. From here, all of my packages should be up to date, and so you want to make sure you're on a completely updated system before you install Coolify. And you can see that because those Cloud Init scripts ran that I put in there, then we don't have any updates. But I'm just going to do it to make sure. And also for anybody that didn't run that script, you're going to want to make sure you do an apt update and an apt upgrade. And it's very likely you might actually have a kernel upgrade as well, so you might need to reboot your machine if you haven't yet. There's a couple of packages that didn't get installed, but everything else is up to date. So I'm on a fully updated machine. I'm ready to install Coolify. So to install Coolify now, we will grab the install script here from the docs, and we'll run it as the root user. Now, the developer of Coolify is working on making it so that you don't have to be the root user, but right now you must run this command as root. And so this is going to download and install everything that Coolify needs to get up and going. And once it's done, we should have a Coolify dashboard. So finished installing, let's give it a go. You can see that it's running over HTTP at the IP address of my server on port 8000. So if we try to go to this, it loads, and this is bad. I mean, it's not that bad, but I don't have a firewall in front of my VPS right now, which means any port of anything listening on my machine is technically open to the world, and I don't like that. We're going to fix that next, but you should get an icky feeling if you ever see ports and you haven't actually explicitly opened these on the firewall. That means everything is open on the firewall. Regardless, let's get this set up. So the name here is CJ. I'm going to give it my email and specify a password. Now, I'm doing a dummy password right now because this is running over HTTP, which means it's not going to be encrypted in transit. So I'm going to change the password later. Great. Now let's get the server set up and then we'll lock things down. So you click on getting started. And next, you're going to need to choose the server. Now, localhost in Coolify terms corresponds to the server that Coolify is running on. So in our case, because we installed Coolify here, and this is where I'm going to be running everything, I'm going to choose localhost. Now, they have more info about this in the docs, but basically localhost is where Coolify is running, and remote is any remote Linux server that Coolify can manage. And they do talk about in the docs that you can use localhost as a server where all of your resources are running, but it's not recommended as high server usage could prevent the use of Coolify. Let's talk about what they mean there. So this is how I'm going to be setting up Coolify, just because this is for demo purposes. I don't have any production apps living here. I should be fine to set it up this way. So Coolify is installed and running on this VPS. Any services I spin up are going to be running on that same VPS. Coolify actually can work on remote instances, though. So technically, you could have an instance where Coolify is running and then point that at some remote VPS, and it would spin up the instances on that remote VPS. And the reason you might want to do this is if for whatever reason any of your services are ever under heavy load, then it might make it so that the Coolify dashboard is inaccessible because like maybe this API here has spiked the CPU to 100% and now you can't even get to the Coolify dashboard and manage things or stop it. If Coolify is running on a separate instance, you would potentially have that capability. And so this is a multi-tiered architecture instead of a single-tiered architecture. And Coolify supports that. The other thing is you can connect multiple servers up to Coolify and also like a build server. But like I said, we're going to keep it simple. I'm going to have a single server where everything is running. And because of that, I'm going to choose localhost. Now from here, I can create my first project. Now, I actually don't want to create a project or resources yet. I want to start to lock things down. So the next part of this tutorial, we're going to set up the firewall and also set up HTTPS. First step in locking things down is to change the password on that secondary user that we created. So I used that cloud init script. It created that CJ user. So now I should be able to SSH in as that CJ user. So if we instead SSH as CJ or whatever you called that user, if you did that cloud init script, it's going to log in. It's going to use your public key to connect because we set that up, but it's going to tell you to change your password. And if you use the cloud init script, the password right now is change me, and then set up your own secure password. So now that that CJ user's password is updated, if I ever SSH into the server as CJ, now if I need to use sudo, so let's say I just want to drop down to a root shell, I'll do a sudo su. It's going to ask me for that password, and now that password works, and it's a more secure password than that default one that we set. The other thing I want to do is I want to set the root password because this doesn't have a password because we logged in with SSH by default. And if we ever need to go into like rescue mode or something, if we ever lose our SSH keys, we're going to want to know what the root password is so I can set it here. So now that I'm in a root shell, if I do a passwd, we can set the root password and just set this to something secure and something that you remember in case you need to drop into rescue mode. Great. So the password's updated. I'm just going to exit out of both of these shells. And so now we have passwords set for both the CJ user and the root user. Now let's get this site hooked up to a domain and working over HTTPS. So the first thing you'll need to do is set up some DNS records. Now I have purchased this domain. It's called apps.gdn. This is all mine. It's mine. I own it, and it's really cool and short. But this is a real domain, and I've set up 2 A records. So I have the Apex domain pointed to that IP address and a TTL of 1 minute. Check out the second video in my self-host series if you want to learn about what all this means. And then also I have a wildcard record set up to point to this IP address. And what this means is I can have any subdomain of apps.gdn, and those are going to resolve to the IP address of my server here. So www.apps.gdn will resolve to this IP. Banana.apps.gdn will resolve to this IP. So at a minimum, I want these 2 records so that any address at apps.gdn is going to resolve to my server. From there, in the Coolify settings, go here and then specify the instance domain. So I'm going to do https://, and I am going to put it under a subdomain. Like technically I could put it at the root apps.gdn, but I don't want people just going there because I'll have other things hosted on the server too. So I'm going to put this at coolify.apps.gdn. I'm going to uncheck validate DNS settings. In my experience, this isn't working very well. So I just want to make sure that this is checked. And then also while we're here in the app settings, I'm going to uncheck auto update Coolify. Now, anytime there is a Coolify update available, you'll get a notification down here. But right now I am on the 4 beta, so changes are happening pretty often. So I recommend that you update manually after you've checked it to make sure that all of the latest features that got pushed are good to go. And so this is another thing to note. When you're watching this tutorial, you could be on a later version of Coolify. I'm on Coolify version 4 beta 2.5.8. And so if you're on anything later than that or earlier than that, things might be a little bit different in the UI. Okay, so I have the instance domain set up here. I'm going to save that. Next, we're going to go into servers and then go to our localhost server here and set up the wildcard domain. This we do want to be the root of our domain. So I'm going to do https://apps.gdn. So whatever your domain is, you want that root domain there. And that means any other app that gets spun up on the server is going to be appname.apps.gdn. We'll save this, and then we're going to head into the proxy settings. So by default, Coolify is set up with the traffic proxy. And that's fine. If you prefer traffic, you can leave this enabled, but I like Caddy, so I'm going to enable the Caddy proxy. Now I'm going to stop the proxy. Now, in order for this to work, you need to make sure that you haven't locked down the ports yet, and you're still accessing your instance over the IP address and port 8000, because once you turn off that proxy, you're going to lose access over port 443 and port 80. So I'm going to stop the proxy, and then I'm going to click switch proxy. And again, make sure I'm still running at the IP and the port here. And I'm going to enable Caddy. Now it says experimental. It's worked for everything that I needed, and Caddy is a lot easier in my experience to configure than Traffic. So I'm going to click on Caddy, and it says the proxy is running. Now, to make sure that all of this is hooked up in the right way, if you go to dynamic configurations, let's see. Yeah, this is good. You want to see this coolify.caddy instance, and you want to make sure that it lists the domain that you put in instance domain, right? So back over in settings, the thing that we put right here, coolify.apps.gdn, you want to make sure that that is listed in your proxy settings in order for this to work. So it's going to be in dynamic configurations, and you want to see that. Sometimes there's a bug where, like, if you switch the proxy or something like that, this doesn't pop up. If that's the case, you might try stopping, restarting the proxy. But if you have this entry, then that means this should work. As long as you have your DNS records set up, you should be able to get to your app via HTTPS. So let's try it. So if I go to coolify.apps.gdn, boom, the login page loads. So at this point, I know I'm good to lock things down further. Now, I do want to mention really quick, the reason I'm using just like Namecheap DNS and not Cloudflare or anything like that is I want to make sure that you understand really what's happening when all of these things are connecting. Because if you use Cloudflare, like technically you might be using its proxy and then like it's handling all of the HTTPS for you. But if you set it up this way, we're setting it up so that the connection from Coolify is always HTTPS. So that's why we're using just a regular plain old Namecheap DNS. You can use any DNS provider, but that's why I'm not using Cloudflare in this instance. I want to make sure we understand how this all connects together. So now that I can get to my app via HTTPS, I'm going to lock down all ports that are not 443 and 80. And we're going to do this with a Hetzner firewall. So here inside of my Hetzner dashboard, I'm going to go to firewalls and create a firewall. And by default, we definitely want port 22 open, or whatever port SSH is running on, that needs to be open. We also are going to add TCP for port 80 because that's HTTP. And then we're going to add another rule for port 443. Now, I'm not going to add a rule for port 8000. And so the moment I enable this firewall, you'll no longer be able to get to your Coolify instance via that port 8000. You can only do it via your instance domain. So I'm going to click create firewall, and this will take a second to spin up. Cool. And at this point, to really test it out, let's try to get to port 8000, right? If I plug this in and the page doesn't load, that's a good sign, because now our firewall is only letting traffic in over port 80 and port 443. Which means the only way we can get to our Coolify instance is by going directly to the Coolify domain. Awesome. With all of that set up, let's lock down our Coolify user account. So let's log in as the user that we set up earlier, and then we're going to go into profile, and we're going to change our password. Now, I highly recommend that you change your password because now we're running over HTTPS. So all of that network traffic is going to be encrypted. And if for whatever reason it was intercepted whenever you were over HTTP, now you can set it to a more secure password. So let's do that. The other thing I highly recommend you do is set up two-factor authentication, because right now there isn't really any protection against brute force login on that password. But if you have two-factor auth, that is one more level of security. Now from here, use an authenticator app. There's a lot of them out there, but this will allow you to have that two-factor auth whenever you're logging into Coolify. Once you add it, you'll get your recovery codes, so just make sure to save those somewhere safe in case you don't have your authenticator app. And then after that, I recommend logging out and then log back in to make sure that your two-factor auth stuff works. So it should prompt you for your one-time code, and we're in. All right, let's set up our first project. And for this, it's just a static website. So I have this Git repo here. It's a public repo, and I want to deploy it as a static website on my Coolify instance. Let's set it up. So I'm going to give it a name. It's called Banana. And then you can specify your environment. So this is one of the nice things about Coolify is every project could have like a staging, a development, a production environment. In our case, we're just going to have a production environment. Each environment can have its resources. I'm going to add a resource here. And in this case, I'm just going to choose a public repository. So I'm going to grab my GitHub URL. We'll choose the server to deploy to. Like I talked about earlier, we're just doing everything here on this Coolify instance, and it's going to deploy this in a Docker container. Now, we specify the Git URL. It's going to do some checks to make sure that it can reach it. And for build pack, we're going to choose static. And so this will really only work if you specifically have a website that is a set of static files. This site has an HTML, a JavaScript, and a CSS file, There's no build process. It doesn't need a node. There's no special process required here. I just have these static files. So I'm going to make sure that I choose this static build pack, and then we'll click continue. Okay, from here, before I click deploy, I want to make sure that I set up all of my domains. So I'm going to add banana here and then click save. And whenever you click save, you're going to want to make sure that you see these container labels get updated here. So the way that Coolify actually links a domain to the actual Caddy configuration or traffic configuration is with labels. And if you scroll down here, you can see the actual labels that are used to specify the Caddy config. So you can see here that it has the domain as banana.apps.gdn, and then it has a reverse proxy to port 80, which is the port that's going to be running for this container that's running this static website. So from there, I'm just going to click deploy, and we're in. And so on any project, if you click on links, you'll see those links that you've set up. If you click on it, you should see your website. So our website is deployed, and it has that nice subdomain. Now I want to set up a www redirect. So when someone goes to www.banana.apps.gdn, I want that to redirect to banana.apps.gdn. And all of this is actually working on top of Docker and on top of Caddy. So if you look at this project here, it's called the Caddy Docker proxy. This is actually what Coolify is using under the hood, and you can read all about it here. So this actually tells you how to specify these labels, which in turn get picked up by Caddy to set up your reverse proxy. So down here, these are the labels that are getting passed to Docker so that this Caddy Docker proxy kicks in and then actually sets up the Caddy configs for us. So the first thing we'll do is we'll just add the domain. So let's just do a comma here, and we're going to add www.banana.apps.gdn. Now, you're going to want to make sure you have that wildcard set in your DNS, but let's just save this. Because if you save this, this should update your labels down here. And now you should see a section for www. But this is the point where we can actually change that configuration. So this, if we left it alone, and actually let's just leave it alone. Let's actually do a redeploy. So now it will actually be accessible from those two different domains, and they both should work. Cool. So now I have two different URLs, and I can go to www, but you see that it doesn't redirect, and then I can go to the root, and that loads as well. But now we want to customize that Caddy config to actually do the redirect. So to do this, it's multifold. First, we need to figure out what is the syntax for a Caddy file from Caddy itself. So we're going to look in the Caddy docs. We're going to go to the Caddy file directives, and specifically the one that we want is the reader directive. And I believe if you scroll to the bottom of this page, yeah, you can see some examples. So basically what we want is for the www entry, we want to redirect that to the root one. And so this is what it looks like as a Caddy config. If you look at the docs for Caddy Docker proxy, you can see how they convert some of these Caddy configs to the labels that are going to be passed in to the Docker container. So let's do just that. So basically we want to replicate this. And if we go back over to general and configuration on our app here, go down to our labels, we want to change the banana.apps.gdn. And so this is labeled as Caddy1. And so every one of these things listed as Caddy1 is technically for our banana.apps.gdn. So what I'm going to do is I'm actually going to delete everything, and especially delete this reverse proxy, because this reverse proxy is what actually is able to load our app running in that Docker container. But what we want is we want to specify a reader. So caddy1.reader. So that'll be a nested property inside of caddy1. And then where do I want to redirect that to? I want to redirect that to the root like this. So that should be all we need. I'm going to save this and then make sure that all of my updates are still there. And then we'll do a redeploy. And so in a sense, this is actually how you configure Caddy, is via these labels. And you're going to need to cross-reference the Caddy server docs to get your right configuration for the config, and then cross-reference the Caddy Docker proxy project to make sure that you're converting that in the right way. Okay, at this point, if I attempt to visit www, you'll see that the redirect happens, and I made a typo. You can see that I forgot to get rid of that dot, but that does mean it's working. So if we dial back in here, yeah, I left that dot. So I'm going to get rid of that. We'll save it. We'll do a restart. Let's see if restart picks it up. I'm actually still unclear on the difference between redeploy and restart. Sometimes my settings get picked up with a restart. Sometimes they don't. Cool. Let's try it. So if we go here, you can see that it redirects. So at the end of the day, this is how you're going to be reconfiguring these redirects and everything else. You're going to want to make sure that you understand the Caddy config, and also make sure that you understand the Caddy Docker proxy labels that you need to specify. Now, in all of my examples, I am using Caddy because I specified that as my proxy server. So if you go to servers and then proxy, at the beginning of this tutorial, we changed our proxy to use Caddy. If you're using Traffic, the process is a little bit different. With Traffic, it has a Docker plugin built in, and it works in a similar way. It works via labels, but you're going to want to go to the docs here to find the right labels. And then whenever you're in a specific project, you would want to make sure that you specify those labels correct here. Now, before we jump into project settings and stuff like that, I do want to show you one more thing on the proxy for the server. So if you go to servers, go to your specific server, click on proxy, we are going to set up a dynamic configuration so that we can have a redirect for our Coolify instance. Right now, our Coolify instance is at coolify.apps.gdn, but if we ever type in www.coolify.apps.gdn, that's not going to load. We need a Caddy config that does that redirect. And so if you ever need some sort of Caddy configuration that isn't specific to a project, in this case, it's specific to the entire instance, you can do that in dynamic configurations. And so you can see here that it's loading them in any of these Caddy files. So here we can specify our own Caddy file. So I'm going to call this instance redirect.caddy. And then in the configuration, we can specify it. So when somebody goes to www.coolify.apps.gdn, we are going to add that redirect directive. So we're going to redir them to https://coolify.apps.gdn. And then you can look in the Caddy documentation or watch the video I did on Caddy for more syntax here, but that's just going to pass in the URI. So once I save this, we now have a dynamic Caddy file that gets loaded in, and it should have reloaded the proxy by default. But now if I try to go to www, it will redirect to the Coolify instance. So this is always super useful if for whatever reason you can't figure out how to customize the tags for a container, you can just create a custom Caddy configuration here, and this will get loaded in, and all of these settings will get loaded in as well. Now let's deploy an application that is more complex than just a static site. We're going to use Next.js, and this will require a server-side runtime like Node.js. So for this example, I just used the Next CLI to generate the app, and there's nothing beyond that. So there's no database. It's not complex at all. It's just the basic Next app, but it will be running with Node.js. So let's get this application deployed. So within Coolify, I'm going to add a new project. We're going to call this Next Example. We're going to choose the production environment. We're going to add a resource. In this case, I'm going to choose public repo. So I'm going to grab my GitHub URL here, and then we're going to throw that in. Cool. And then for build pack, we are going to choose nixpacks. Now, it is possible that if you have a Dockerfile within your GitHub repo, you can choose Dockerfile. If you have a Docker Compose within your Git repo, you can choose Docker Compose, and it'll just use that file that lives in your Git repo. In our case, we have nothing related to Docker in our repo, so we want some magic, and that magic is going to come from nixpacks. Now, nixpacks is an open source project that was started by Railway, and essentially it's the magic in one-click deployments. And so this is how Coolify gives us this nice one-click deployment experience. We don't have to know anything about Docker. We don't have to create a Docker file. All of that is handled by nixpacks. And so essentially, nixpacks is going to look at the source code for the application you're trying to deploy and then automatically figure out how to containerize it and how to build it and how to start it and everything else. And so if you look at the nixpacks documentation, you can see that they support a lot of different languages and runtimes. And essentially what's going to happen is during the build process, it's going to look at your source code to determine the kind of application. And in our case, it's going to see that package.json and say, oh, I know this is a Node.js application. And then from there, it's going to say, oh, I'm going to use the convention that there's probably a build script in there and a start script in there. And it's going to use those whenever it's setting up our container. So we're going to use just the default settings of nixpacks here. But if you ever want to customize that build and you're going to be using nixpacks, you can customize it with environment variables. So if you check out the nixpacks documentation, they list all the environment variables that you can set. You can set these within your Coolify resource settings, just add them there, and nixpacks will pick these up and use those custom settings. Now, you also can customize nixpacks with a file. You would need to commit this file to your repo for it to be picked up. But what I'll show you in a second is there are a few things that we can customize within the Coolify dashboard that you don't need the nixpacks file for. So from here, we'll just click continue. And now we have our app set up. So the first thing I'll do is just set my domain. I want this to be nextexample.apps.gdn, and I'll click save on that. So down here is where we can customize the commands that nixpacks will run for install, build, and start. But because this is a Node app, it's going to look at the package.json. It's just going to run that build script, run that start script. Now for the install, it is going to look for a lock file in your repo and then run the according install. And in our case, we have a package lock, so it's going to do an npm install. But if you have a yarn lock file or a PM lock file, it will run and install with those instead. So if you look in the nixpacks documentation for Node, you can see that it will do just that. It's going to look at the lock file and determine how to do an install. So because we don't need to customize anything, we should be good to go. I'm just going to click deploy, and we'll see what happens. I'll also show the debug logs here and kind of like talk through what's happening. So yeah, by default, you can see right here, it has detected that this is a Node.js application, essentially because that package.json exists, and it's telling us the commands that it's going to run. And again, we could override those in the settings if we wanted to. Now from here, it's going to run the build. It now generated our Docker image for us, and now it's attempting to start it up. And so when you use nixpacks, it uses this thing called a health check, and by default, that's just going to be the index route of the thing that you're spinning up. And so in this case, it will determine that the container is healthy if it gets a 200 status code by requesting the index page here. And so you can see there are a couple of checks, and then finally it got a 200 status code, so it says that the service is up and running. If you click on deployments, you can see there was a successful deployment there. If you click on logs, you can see the actual container logs of the running Next.js application, and now we should be able to visit it. So if I click on this, the app loads just fine. Great. So this was a super basic example. There's nothing complex. We don't have a database. There's no custom build. But for some Next.js applications, this might be all you need. You essentially just say use nixpacks, everything else is handled for you, and your app can be deployed just like that. Now, up until this point, the projects we've deployed have just been a public Git repo. Now I want to set up a GitHub application so I can deploy private repos and also get automatic deployments via webhooks. And to do this, we're going to go over to sources and we're going to create a GitHub application. So I'm going to click add, and then we'll give it a name. And so this needs to be unique across GitHub. So I'm just going to call mine Coolify apps GD, and you might have to play around with the name to make sure you get a unique one. And then for webhook endpoint, you're going to want to make sure that you choose your HTTPS URL. So at least from what I've seen, there have been some issues delivering webhooks to HTTP URLs. So make sure you choose your HTTPS URL and then click register now. So this is going to take you over to GitHub, and you're going to create the app on GitHub. And so this name has to be unique. And if it is unique, the app will be created. Now from here, we need to choose which repositories are available for us to use within the GitHub app. So we'll click on this. This will take us back over to GitHub, and we can choose. Now, you can give it access to everything. You can just say you can have literally all of my repositories, or you can select specific ones. Now, I believe in the principle of least privilege, so I'm only going to select the projects that I want to deploy. And for now, I'm just going to add the same Next app that we added earlier, but we're going to redeploy it, but also demonstrate getting automatic deploys with webhooks and stuff like that. Okay, so we've given it access. I'm going to click install. And so now we're good to go. Now to check and see if everything is configured correctly, click refetch. And as long as this comes back, you can see that this GitHub app that we've created actually has permissions to read from our repos. And if you ever need to add new repos to that list, you can click this button. That'll take you back over to GitHub. You can add the repos that you'd like here, and then save them, and then head back over to your Coolify instance. Now let's deploy that same Next app, but we're going to use this GitHub app integration. So I'm going to click add. We're going to say another Next app. We'll choose the production environment, and then we're going to add a resource. And in this case, we can choose private repository with a GitHub app. So we'll click that, choose where we want to deploy it, and then choose the GitHub app that we set up. Now here, you'll get a drop down of all of the repos that you've added. In this case, I've only added one repo, so I'm going to select that one and then click load repository. Now, just like before, we can choose nixpacks, and the default setup should work for us. We're going to update the domain here to be another Next app. Click save and give it a go. So I'm going to click deploy. Okay, so the deploy finished. We should be able to visit our application, and it works just fine. That's awesome. But now we want to demo this GitHub integration. So if you go to configuration and then you go under webhooks, you'll see that you can't do anything for manual Git webhooks because these are automatically set up for us. And essentially what's going to happen is if I push a commit to this Git repo, GitHub will then make a post request to my Coolify instance, which will then detect that and then pull in the latest changes and do a rebuild and a redeploy. So let's try that now. So I have here in the source codes, I'm just going to make a quick little edit and just say auto deploy with Coolify. Save it, and then we're going to commit it. Okay, so I've committed my changes. Let's push them up. Good to go. So the commit has been pushed to GitHub, and if we head back over to Coolify and we click on deployments, we should see that a deployment has been triggered, and you can see that it was triggered via a webhook. So if we click on this, we can see the build progress, and once it finishes, we should be able to see that update. Okay, so it finished, and now if we visit the application, we should see that update. Yeah, auto deploy with Coolify. Nice. So since we set up that GitHub application, essentially anytime a new commit comes in, GitHub will then make a post request to the webhook that Coolify has set up, which will then trigger a rebuild and a redeploy. And so we have that nice automatic deployment experience every time a new commit gets merged into the main branch of our repo. Now let's see how to deploy a slightly more complex Next.js application. So I have here a T3 app, and this is using a Postgres database and also has next auth with GitHub OAuth. So we're going to set that up now. I'm going to call this the T3 example, choose the environment. We're going to add a resource. Now, the first thing I'll do is just add a Postgres database because our app needs access to one. So I'm going to create one within this environment. Cool. I'm going to give it a useful name. We're going to call this our T3DB, and we're going to save it and then start it. So now, just like that, I have a Postgres database up and running on my Coolify instance. Now, it's possible to connect to this database remotely, like over the public internet, and you would have to check make publicly available here. But you would also need to configure your firewall. So you need to go into your firewall and then make sure the specific port you want this to be accessible on is open. I want to keep everything within my VPS. I don't want to access it remotely, so I'm just going to keep this going here. But we do get this Postgres URL, and I'm even comfortable sharing it with you because it's not accessible over the public internet. It's only accessible within our Docker network here because it's using the container host name there. So this URL can be used by any other container here in Coolify to connect to that database. And so that's what we'll do. Now I want to push my schema to this database. And so my app is using Prisma, and I need to push the schema. Now, like I said, you technically could go in here, make the database public, and then push that schema from your local machine. But I'm going to do all of this within Coolify itself. And to do that, I am going to create a Docker container. So I'm going to go to new, and here I'm going to specify a Dockerfile. Now, if you're new to Docker, it's not that hard. I have confidence that you can figure it out. Also, I've done a video on Docker if you're interested on learning more about it. But basically what we're going to do is we're going to write out a Docker file that clones the repo, installs the dependencies, and then does a Prisma DB push, and also starts up Prisma Studio so we can look at our database. So follow along. We're going to say from node. So we're going to grab the Node.js base image because this is going to give us node and npm. Then I'm going to specify my working directory, and I'm going to specify that to be /app. And then I need to clone my repo. Now, if it's a public Git repo, this is going to be super easy. Just grab the HTTPS URL, and I'll show you what that looks like now. So you'll just say run git clone, paste in the URL, and do period. So that'll clone this URL into the /app directory. From there, we just want to do an npm install. So run npm install. And then from there, we want to push the DB schema to the database. So I can do run npx prisma db push. And then lastly, we're going to use command to say what command should be run after the container has spun up. And in this case, we'll do npx prisma studio. So this is a little container that clones the repo, installs dependencies, pushes the DB schema, and then starts up Prisma Studio. So I'm going to go ahead and save this. And I'm going to give this a domain. So I'm going to call this studio.t3example.apps.gdn and then save that. Now, in order for the DB push to work, we do need to add an environment variable. So I'm going to go grab that connection URL from our database here. We'll copy it. And then if we go back into our app here, and also I'm going to update the name just so we remember what it is. So this is the Studio T3. Save that. And then in our environment variables, we can add one called database URL. Paste in that value there and then save it. Now, this is a build variable because when we're building the container, Prisma is going to need access to that environment variable. So I'm going to make sure that that is a build variable. Now from here, if I want to be able to access this Prisma Studio, I need to make sure that the port is set up. And so by default, Prisma Studio runs on port 5555. So I'm going to set the exposed port to that, click save, and then click deploy. So it looks like it's done. Let's try to visit it. So if we click this link, Prisma Studio loads up. Now, of course, you don't want to leave this running all the time, especially because it's not password protected, and anybody that goes here can literally change our database. But this is good to know that it's up and running, and all of our tables have been created. So I'm going to go ahead and just stop this container for now because I know the database is good to go. And then I'll show you how we can do this same thing if we're working with a private repo. So if you need to do this kind of thing from a private repo, you won't just be able to clone directly from the HTTPS URL. You're going to need to clone from an SSH URL, and you're going to need to set up a deploy key. So let's do that. So first thing we'll do is over here on the server, we'll do keys and tokens, and we're going to create a new private key. Now I'm going to click generate this key here, and I'm going to give it a name that matches the application that I'm deploying. So I'm going to call this T3 example. Now, you should never leak your private key. I'm going to delete this the moment I'm done recording this. But don't leak your private key because anybody that has that will get access to wherever you set up this public key. So we're going to click continue. We now have this key set up. Now what I need to do is I need to add the public key here to our repo so that this private key can get access to that repo. So on your GitHub repo, go over to settings, then go down to deploy keys, and then add a deploy key. I'm going to paste in that public key, and we'll just call this our Coolify apps GDN, and then add the key. And I'm not going to allow write access. So basically, with this key, if for whatever reason the private key got leaked, they would only be able to read from this repo. They wouldn't be able to write to this repo. So we've added the key to GitHub, but now I need to use this private key inside of that Docker container whenever we're cloning the repo. So I'm going to copy this key, and then we're going to go back over to our project and update that Dockerfile. Now I need to put this private key into a private key file. So I'm going to write a command that does just that. Now this is a lot of codes to write out. So I'm going to link a gist in the description of this video so you can copy paste and kind of just update with your own stuff if you want to do this. So the first thing we'll do is we'll create an SSH directory, and this is where we're going to put our private key. Then we need to say run echo. We'll do some double quotes. We want to put this into the SSH folder into a file called id_ed25519. So this is the algorithm used to generate the key that we generated earlier. And so that's the name of the file that we're going to give it. Then we need to change the permissions of that file. So I'm going to say run chmod, and we'll say 600 for that specific file. And then lastly, we need to add github.com to our known hosts file. So we'll say run ssh-keyscan-t rsa github.com into our known host file. Now, be sure to check the description. You can copy these commands to run in. Now, the last thing we'll need to do is to actually put our private key in between the quotes here. So I'm going to save this. We'll go back over to our keys and tokens, grab our T3 example. Let's grab our private key. We'll copy it. And now we're going to paste it in between the double quotes here, like so. But we do need to add new lines. So I'm going to escape the new lines and then do a / to say that this should continue on the next line. So at the end of each line, I'm going to add this, so that way the new lines will exist within that file as well. From here, we should be good to go. We create the SSH directory, we create our private key, change the permissions, add github.com to the known hosts, and then we clone the repo. But now, instead of cloning from HTTPS, we need to clone from SSH. So if we go over to our repo, we can grab the SSH URL and throw that in right here. And we'll save this, and then see if it works. Now, it's important to note that because we've set this up manually, this isn't going to automatically deploy whenever we push to the repo. But this is a nice way of at least being able to run all of these commands I need to run within the Coolify instance instead of having to run these commands remotely. So if everything works here, then it should push the DB schema, which it's already done. There shouldn't be any changes that need to be made, and then it'll spin up Prisma Studio as well. Cool. We can test it out. If Prisma Studio is still running, that means all the other commands ran as well. From here, I'm going to stop the Prisma Studio container because, again, I don't want that running 24/7. Anybody that finds it would be able to mess with my database. So I'm just going to stop that instance so that way Prisma Studio isn't running anymore. Now let's actually deploy our T3 app. So I'm going to go add a resource. And in this case, we will use our GitHub app so we can get automatic deploys. So I'm going to click on this, click on our server, and then our GitHub app. And I want to choose the T3 example. So I'll click on that and then click load repository. And in this case, we can use nixpacks. So I'll use nixpacks. It is running on port 3000 and I'll click continue. Now let's update the domain. I'm just going to call this t3example.apps.gdn. We'll save that. And we need to now set up all of our environment variables. So you can add these one by one, but what I really like is the developer view because you can actually just copy paste these in from like a .env file and it'll load all of multiple environment variables all at once. So I'm going to set up all of my environment variables up really quick. So I've added all my values here. The database URL is just like we set up for the other container, and it's just the one that we copy pasted from the Postgres database that we spun up. For next auth URL, this is just going to be the instance domain. So whatever you set in general, that's what you're going to want to set up there as well. For next auth, you're going to want to generate a secret. And in my case, I'm using GitHub OAuth. So this is my client ID, and then I'm going to plug in my secret as well. After you save it, you should have all of your environment variables set up here. And this should be everything we need to start up the app. So if we go back over here and then click deploy, cool. So it says it has been deployed. We can try visiting it. Awesome. And so now we can sign in. So I will show you really quick my GitHub settings if you are using GitHub OAuth. Essentially, I've set up the authorization callback URL. So whatever type of OAuth you're using, you're going to want to make sure that you specify your actual instance domain. And then depending on what your auth provider is, make sure that you have the correct callback path there. But because I have that set up correctly, we should be able to log in with GitHub. So I'm going to click sign in with GitHub. I get redirected back. So I'm now logged in as CJ in my app here. So I just modified the T3 example. Now we have a posts page. So if we go to posts, now we can add things like hello world. And that actually gets put into the database. Let's see, like another one. That. Awesome. So it's working. So we have a T3 app. It's connected to our Postgres database. It's storing users that are via GitHub OAuth. We're good to go. Now, since we're using Caddy as our proxy, I actually want to show you how you can lock down certain things with HTTP basic authentication. So take, for example, our Prisma Studio that we set up for our T3 example. When we run this, anybody can visit this site and access our database. So I'll deploy this really quick. And when we visit it, we can see our T3 example. We can see all of our posts in the database. We can see all of our users in the database. And this isn't good, right? Because if somebody had this URL, they could just access our entire database. But one thing I can do is I can protect this page with HTTP basic authentication. And so let's set that up with Caddy. So earlier we talked about how we can use these container labels to actually set up custom Caddy configurations. And within Caddy, we have the ability to set up HTTP basic auth. So if you look in the Caddy docs and then you go to directives, there is one called basic auth, and they show some examples. So what you can do is add a block here called basic auth, specify the username and then the hashed password. And now it's going to protect that resource with HTTP basic auth. So let's generate a password. You can see here that Caddy has a built-in command called hash password. So let's use that. So we can use Caddy from the command line, run hash password, and it'll spit out a hashed password. Now, I don't have Caddy installed on my machine, but our VPS has Docker installed on it, so we can actually spin up a Docker container, use the Caddy command from within that Docker container, and then spin it back down. So if we go over to our server, I can do sudo docker run, specify the image name. In this case, we're just going to use the default Caddy image, and then I can specify the command that I want to run. In this case, I want to just run this command here. So I'll say Caddy hash dash password, and then specify the password I want to hash with -p. So we'll just say -p, and then the password that we want to hash. And then that'll actually spin up a container, run the command, and then spin the container back down. But this is the hashed password that I need to use. So we'll go back over to our container labels. And basically what we need to do is for this Caddy 0, we want to add a new block called basic auth. So very similar to how like handle path here is adding a new block. we will add one here. And so we'll say caddy underscore 0. We'll say dot basic auth. And the next line then needs to be username space password. So what we can take the reverse proxy as an example, because handle path has on the next line reverse proxy and then the value itself. So what we need to do is dot 0 underscore. And so that basically puts us on the next line. Then I want to specify the username. In this case, it'll be CJ. And then the value will be that hashed password. So I'll throw that in there. And so this should be all we need. And now anytime someone goes to this page, it's going to use HTTP basic auth before you can actually access the resource on that page. So I'm going to save this and then restart the container, and we'll try it out. Okay, it restarted. Let's visit it. And this is a good sign. So if you see this, it is prompting you for that username and password that you set up. And if you type it in right, you should get in. Now, I will say this isn't the best type of authentication because it is vulnerable to brute force. Like someone could basically try a bunch of username and password combinations, and we haven't set up any protections for that. But this is nice for like little one-off instances, right? So if every now and then I want to spin up this Prisma Studio, I can at least have to type in a password to get to it. And then when I'm done with it, I can just spin it back down. And again, this is also just useful for any resource you have where you just want to quickly throw up a password in front of it. So whenever Coolify has an upgrade, you'll actually see this little icon here in your dashboard, and you can upgrade to the latest version. Now, currently I'm on v4 beta 266, which is actually even later than what I was at earlier in the video. So I've updated a couple of times while recording this. But if you head over to the settings tab earlier in the video, we disabled auto update. And so typically I leave this disabled, and then I keep an eye on the Coolify Discord and also the GitHub issues to make sure that the latest beta release is at least stable enough to use myself and hasn't broken anything. So I checked the Discord, I checked the issues, everything seems good. So I'm going to click upgrade. Cool. And it looks like we are updated to version 268. I'm just going to refresh my app here. So after this upgrade, it's very likely that the Docker containers needed to restart, especially the Coolify proxy, which is what is actually managing access via this instance domain here. So I'm going to give it a second to make sure that all of the containers have restart, everything's good to go. And now you can see I'm on version v4 beta 268, and I don't see that upgrade option anymore. Now, let's see an example of deploying an application that has an existing Docker Compose file. So I have this app here. It's called Pokemon Cacher. It is a Node.js and Express API that caches responses from the Poke API into a Redis database. And if you take a look, there's a branch called with Docker Compose, and this branch has a Dockerfile, which Dockerizes the Node.js application, and then a Docker Compose, which loads that Dockerized Node app and also spins up a Redis database. So I want to point Coolify at this repo and tell it to use this Docker Compose file. So within Coolify, I'm going to go to projects, add a new project. We'll call this Pokemon Cacher. Choose production, and then we'll add a resource. Now from here, I'm going to choose private repo, and I have given my GitHub app access to that repo that I'm trying to deploy, so it should work. And then from the dropdown, we want to choose that repo. We'll load it in. Now here I want to choose the branch, so I'm going to say the with Docker Compose branch, and for the build pack, I'm going to choose Docker Compose. Now in the last version, there was a bug where when you click continue, it changes the build pack. Yeah, so that's still there. This will be fixed soon, but right now the build pack reverted back to nixpacks. I want to choose Docker Compose, and then we'll use that setting. So by default, it tries to load the Docker Compose file from docker-compose.yml. In my repo, the file is docker-compose.yml. I didn't debug this for 2 hours. So just make sure that the name that you have here matches the name that you have in your repo. So I'm going to remove that A, click save, and then you should see the Docker Compose file get loaded in here. Good. So by default, it'll load the Docker Compose, but it's also going to show you some of the labels that Coolify adds in order to manage these containers. So that looks good to me. From here, I want to set up all of my environment variables because you'll see that the Node app has several of them that it depends on. So I'm going to go over to environment variables, click on developer view, and then within my app here, I have an env sample file. So I'm actually just going to copy this, paste it in, and then update accordingly. So the Node env here is going to be production. And then the Redis host actually can be what's listed in my Docker Compose file. So in my Docker Compose file, the Redis database service name is just DB. So because they live within the same Docker network, I can put DB here and it'll be able to connect to it. It's listening on 6379. And then by default, that Redis instance is in unprotected mode. So it actually doesn't have a username and password. So I can remove that and it will be able to connect. Now I'll save this and then we should be good to go. Now I will say the fact that it's running in unprotected mode is okay because this Redis database is not exposed to the public internet. So this Redis database is only accessible within this Docker network. So for these purposes, it's okay to not have a username and password. Now, I want to set up a domain for my Node app here. And Coolify has kind of detected that I think because this thing is exposing a port, you have access here to set the domain for it. Now I'm going to set it. So I'm going to do https:// we're going to call this Pokemon Cacher.apps.gdn. And I'll save that. Now let's give it a try. Looks like there was an issue with the deploy. It says service app at ports at 0, expected a map, but got a string. What does that mean? I don't know. We can see here the generated Docker Compose file. It has ports listed, and then we have our 2 ports there. Okay, so I did a bit of digging. I think it's because I was exposing the ports for both of these services. And the way Coolify works is it actually doesn't necessarily need to expose the port because it can access the port via the IP address of the container. So what I did is I updated the Docker Compose to remove those port mappings for both app and DB, and I put it on a different branch. So let's try changing the branch. I'm going to go over to source and then change the branch to be Coolify Docker Compose. So this is the new branch that I made. So I'm going to save that. And then over on general, I'm going to reload the compose file. And so I'm not seeing the latest Docker Compose loaded in. Let's actually do this. Let's trick it. let's just change the name to something that doesn't exist and then try to reload it. So I'll save that. Okay. It's not reloading the Docker Compose. I'm just going to delete the project and start over. I have found with Coolify, if I'm debugging stuff and I get to a certain point, I'm just going to start over. So let's add a new resource. I'll pull it in from the same repo, choose my repo here. Yeah, make sure that it's the Coolify Docker Compose branch, choose Docker Compose, update the build pack, and then tell it where to find the file. There we go. So that pulled in the updated Docker Compose. Good. And then I'll go ahead and set up all my environment variables in the same way. Awesome. So updated my environment variables, set the domain. I'm going to save it. Let's try deploying again. Cool. Let's check out the container logs. So we have Redis is running and then the app is running on port 5000. So let's try to visit our app. It's not loading. I think one thing we're going to have to do is specify the port that the app is listening on. So right now, if we visit our site, if you see a 502 error, this is a bad gateway error. So this is coming from the Coolify proxy, and it basically just means that it cannot proxy to that specific application. So let's take a look at our configuration and see the labels that were generated. So right now, for the app, you can see that it has upstreams, but it doesn't have the port number. And so one of the things you can do when you're specifying a domain is you can actually put the port number on the end. You can see that in these examples here. So if I do :5000 and then save that. From there, I will click reload compose file. We want to make sure that it picks up that setting. And then if you look in here, so we're going to look under app and look under our labels and make sure that our Caddy label for reverse proxy is updated. It is. So you can see it says upstreams and then port 5000. So now we shouldn't get that bad gateway because now it's going to know to proxy it to port 5000 of this running container. Now, do we need to redeploy? We do. So I'm going to redeploy. That should pick up those labels that got added to the container, and it should set up the correct reverse proxy to our application. Cool. Let's look at the logs again. No errors here. We'll do a refresh. We get an application. Sweet. So sometimes you might have to debug a little bit like that, but it really just comes down to checking your status code, making sure that the labels have got set in the correct way, and then the application is loaded. But let's give it a try. So if we go here to API/v1/Pokemon, and then put in a Pokemon name like Pikachu, should get back a response. Nice. And the fact that it's even showing this to me tells me that the Redis database connection is working as well, because it wouldn't even return the values if it wasn't able to put it into the Redis database. I think we can also see how fast the response comes back. So yeah, this initially took 273 milliseconds, but now it's in the Redis cache. So if I refresh, 46 milliseconds. So it's definitely loading that data from the Redis database now. Next up, I want to be able to see the status of my full VPS, like CPU usage, memory usage, that kind of thing, from some kind of web dashboard. And there's a lot of ways to set this up. I'm going to use a tool called Glances. It actually looks like it's running in the terminal, but you can visit it from a web browser. It's based on Python. We can run it in a Docker container. So I'm going to set this one up because it's fairly simple to set up. Now, another way to get these kinds of stats is by using a stack that includes Grafana, which is like an open source web dashboard where you can add all kinds of visualizations, but there are tools that can report data to Grafana, and then Grafana will allow you to visualize it. So to get VPS stats, you use a tool called Prometheus and then another tool called Node Exporter, which exports the data to Prometheus, and then you add a Prometheus importer into Grafana. And so that's one way of going about it. This is nice because you actually can set up things like email alerts or like Slack notifications if you have high CPU usage or if a server goes down or something like that. So for big production deployments, this is a very nice stack to have. Another one that I tried out, which seemed fine, but they do have like a paid plan, is called Net Data. And so they actually give you a command where you just run this directly on your VPS, and then they give you a web dashboard that will show you the stats of your server. So that's one way to go about it. Like I said, I'm just going to use Glances for now because it's fairly simple to set up with Docker. And it just gives us a nice little dashboard where we can quickly see things like CPU stats and memory usage and all of the stats of the containers that are running. Pretty much any service that offers up a Docker image or Docker compose file can be run with Coolify. And so in the Glances documentation, I went over to their Docker docs, and they actually give us this Docker compose that's kind of like ready to go. So this is what we're going to use. So within Coolify, I'm going to add a project. I'm just going to call this VPS stats. I'm going to go into production, add a resource. And in this case, I'm going to choose Docker compose. Now here, I'm going to paste in the Docker compose file. Now, a lot of examples you see out there with an existing Docker compose file like this, like whether or not it's Glances, like there might be something else that shows you how to run it with Docker compose. They might actually have a proxy listed in the services here. And because we're using Coolify, we don't need that. So what I'm going to do is I'm going to grab this whole Docker compose file here, but I'm going to get rid of the proxy because we're going to use the Coolify proxy instead of trying to spin up our own container. So I'm going to get rid of that. And so in this case, really all we need is the Glances image. And I am going to uncomment this line here because I wanted to show the info about my actual VPS. We also can get rid of these labels because we're going to be using Caddy, and those are all going to get added automatically. Now, for Glances to be able to work, it does need access to this Docker sock, and so that's how it's able to show us the status of all of our running containers. And then the other thing is this setting right here, PID host. In order for it to show all of the processes that are running on the main VPS, it needs this because otherwise it would only show you the processes running on the container itself. So this should be all we need. I'm going to save this, and then I am going to give it a domain name. So I'm going to go into settings here, and then we'll just call it, let's do stats.mydomain. And then we need to specify the port that it's running on. So if we look in the Docker compose, 621.208 is the actual port that Glances runs on. So here we'll just say :that, and then save it. Now, if we go back, we should be good to go. Let's deploy it. Awesome. And now if we try to visit it, we get a nice little dashboard. So you can see it tells me that my server here is running Ubuntu 22.04. We can see our current CPU usage. We can see all of the containers that we have running. So these are the containers that are managed by Coolify. And then we can see the processes on the server as well. So this is nice to spin up every now and then if I don't want to necessarily like SSH into the server and I just want to see like some stats at a glance. Now, you definitely want to protect this page. So right now, anybody could visit this page and see all of the stats of my server. But earlier in the tutorial, I showed you how to set up HTTP basic auth. So you should set that up for this domain as well. I'm not going to go through the process of doing that again. Check earlier in the tutorial when I set it up. But basically what we can do is inside of the compose file, we can add labels. So here under labels, we can add one for Caddy 0. So if we do Caddy 0, we do basic auth, and then specify our username, and then paste in the password that you generate using the Caddy hash password. Save that compose file, restart the container, and then you should be prompted for a password whenever you visit. Now, if we try to visit the app, it should prompt for username and password, and we're in. Now let's see an example of deploying an existing service stack. So this is a one-click deployment that's built into Coolify. So in this case, I'm going to try supabase. So I'm going to add a project. Let's call this supabase. And then from here, it'll be in production, add a resource. And then if you scroll down here to services, these are all one-click deploys. So these are pre-configured to work with Coolify, and they're literally just one-click deploys. So in here, there is a supabase. So I'm going to try it out. So I'll click on supabase, choose where I want to deploy it, and it's almost ready to go. So it generates a username and password for me to log in with. And you can see that it also generates the domain for the supabase instance. So this is what I'm going to update. I'm just going to call this supabase.apps.gdn like that. So we'll save it. And then from here, we will deploy it. And this actually requires quite a few containers, as you can see, and it's going to have to pull all of these images and start them up and everything else. And so this is a good use case for actually checking out glances while this is happening so we can see that CPU usage. So I'm going to click deploy. It's going to need to pull all of these images, and let's just keep an eye. Yeah, so it's pulling all of these. Let's keep an eye on glances while this is happening. Yeah, so on my machine, which has 4 CPUs, we're already at 50% CPU usage. And then memory, we're only at 25%, down to 30, back up to 60. Things are starting, 30, 100%. So something happened that's actually like really spiking the CPU usage right now. Yeah, so you can see that it went way up. And then now the containers are up and running, and it should start to spin back down to idle. But this is something you need to look out for. So supabase itself probably requires 2 CPUs and I think at least 2 gigs of RAM. Your mileage may vary. It's going to depend on what you're trying to do with it. But there are a lot of services going here. So just supabase itself actually needs that much resources. So the VPS that I have this running on, I think has 4 CPUs and 8 gigs of RAM. So right now we definitely are kind of like pushing the limits, trying to run both Coolify and supabase on it. But yeah, you can see my CPU has dropped back down to about 17%. And now we can see if it loads. So let's try visiting it. Yeah. And it prompts for username and password. And so we can just grab that right here. So it generates a user for us. And then it also generates a password. So I'm going to bring this in. Cool. And we're in the supabase dashboard. So from here, I can just use this maybe in one of my other projects. So like if I go over to the API docs, you can see that it actually has my domain that I have specified here. And I could use these API docs to actually use this supabase database within one of my other projects. Next up, I want to show you how to set up minIO, which is S3 compatible object storage. So S3 is actually something that comes from Amazon. It's their object storage offering. But there have been some projects that have popped up that basically give you S3 compatible storage. And what that means is we can self-host this minIO, and it will behave just as if we were hosting something on AWS S3. And this is useful for a lot of things. If you're implementing, for instance, like file uploads in your application, you can set minIO as the destination for those uploads, and it has the exact same API as Amazon S3. And so your app will be able to connect to it in the same way. Also, Coolify actually supports automatic backups. And so once we get a minIO instance up and going, we can schedule Coolify to create backups, and it'll actually upload those backups to the minIO S3 compatible storage. So that's what we would like. Let's get it going. So I'm going to add a project, and I'm just going to call this storage. Now, I will say I'm creating all of this stuff on the same Coolify instance. A good backup is actually offsite. So it's on a different server, because if something bad ever happens to this server, all of my backups that I'm storing inside of minIO are gone as well. So a true production setup would actually have minIO set up on a separate server, potentially multiple separate servers, and then you have multiple backups, multiple offsite backups. But all of that said, I'm putting it on this same server. It'll work in the same way if you set it up somewhere else. So Coolify actually has minIO as a one-click deploy. So just search here for minIO, click on it, choose your server and network. And now our minIO instance is ready to go. So first thing I'll do is just update the S3 URL. So I'm just going to call this storage.apps.gdn. And then I'm also going to update the console URL, and I'm going to give it a subdomain. So I'm going to do console.storage.apps.gdn. We'll save this and deploy it. Cool. Looks like it's ready to go. I'm going to copy that admin username. And then if I visit the console, this is the web dashboard, and I can log in. So I'll throw in my username there, and then I'll copy my password. Great. Now we can create buckets. We can create access keys. So let's go ahead and do that. I'm going to create a bucket, and I'm going to call this DB backups. and we'll just leave all the default settings. So now I have that bucket there. And then there's a lot of different ways you can go about giving access to this bucket. You can actually like create users and create like fine-grained controls. I'm just going to create an access key that has access to all of my minIO storage here. So I'm going to create this access key. You can set up expiration and everything else. But I am just going to give this a name. I'm going to call this the DB backups key and click create. Now it's going to prompt you to download these and copy them because it's not going to show you this secret ever again. So make sure that you do that. From there, we can now use this access key and secret to upload things to this bucket here. Now, the other thing I'll do is set the region name. So if you go down here to configuration, you can set the server location, and I'm just going to use like the S3 convention. So I'm going to say US West 1 and then save that. And so now whenever we're configuring the connection to it, we can use that specific server location, and I'm going to have to restart the instance. So that's good to go. Now there's so much more you can do to configure and set up like site replication and again, like further more restricted access policies. Check out the minIO docs for all of that. For our purposes, super simple. We just have a bucket. We have an access key. I want to upload things to the bucket. So this is what we'll use whenever we're setting up our database backups. Next up, I'm going to configure backups for the Postgres database that we added to our T3 example earlier. So if we go in here, go into our app, go to our Postgres database, you'll see that I have this backups tab here. And so this backups tab exists on any of the database resources that are like one-click deploys from within Coolify. A couple of them don't have backups configured just yet because there's a specific task that needs to be run in order to back up that database. In the case of Postgres, there's pg dump. And so this has been pre-configured to run pg dump. So let's schedule a backup. Now for frequency, we need to specify the cron tab syntax. And if you visit crontab.guru, they give you a nice little UI that makes it easier to understand what's happening here. You also could just ask ChatGPT. It probably could spit it out for you. But for instance, if we say minute 0 and then hour 0, this syntax says run every day at midnight. And so just for this example, I'm actually going to run it every single minute. And so if I use this syntax, it's going to literally do a PG dump every single minute. And I'm just going to do this so that way we can actually see these dumps happening. Now, when and how often you back up your database is dependent on many, many different things. So like how often is the data in your database changing? How likely is it that something might go wrong on the server? And how much guarantee do you want to have? Because you could run this, let's say, once a day or twice a day, but anything that has been added to the database since your last backup will potentially be lost. And if you do it super frequently, like every minute, then potentially your server is going to have to be spinning a lot of CPU to run that backup. So there's a lot of things to consider when scheduling a backup. So take that into account and also search the web. There's better there's better info on it out there than what I can provide. But for this example, we're going to back up this database every minute, and I'm going to click save here. Now, by default, Coolify will actually store these backups on the Coolify instance itself. So if you look at the frequency here, after a minute has passed, we actually will get access to one of those backup files. So let's just wait for that to happen. Great. So we can see that the last backup was a success. We could download it if we wanted to. And you can also see the number of backups to keep. So these are the backups on the Coolify instance itself. And so this is going to depend on how much storage you have on this VPS. So you can set the number of backups that should be kept locally there. But next up, we're going to set up this S3 backup. So instead of just backing up to this Coolify instance, it's going to upload it to our S3 compatible storage. So to do that, we can go over on the left-hand side to S3 storages. It will say this is a recent addition to the left-hand sidebar. Make sure you're at least on beta 269 to see this in the sidebar. Before it was under Teams, and then there was like a storages tab, but now it's over here on the left. So we're going to add a storage, and we're going to add the minIO instance that we set up earlier. So we're going to click on add. We're just going to call this our storage. The endpoint is the storage endpoint. So what we set up earlier was https://storage.apps.gdn, and then the bucket we created was called db-backups. So just make sure this matches the bucket name you created. And then the region we set was US West 1. So just make sure that all of these values match what you set up for minIO earlier. And then add your access key and secret. So I'm going to copy these values in. We're going to validate the connection. And if it was a valid connection, it'll add it. So now we're ready to go with this S3 connection. So anytime a backup happens, it'll also be uploaded over the network to this storage endpoint. So if we go back to our project and then under backups, we can now check S3 enabled and then choose the storage that we set up earlier and then click save. And so now anytime a backup happens, it will be backed up locally. So we'll have access to that local backup, but it'll also be backed up to the S3 compatible storage that you set up there. So if we head over to the minIO console, we can actually see that Coolify has created a directory here, and it's going to create a directory for every database that you're backing up. So we have our team, and then we have our specific instance. So this instance name matches the internal instance name of that specific database, and then we can see these PG dump files. And so every time one happens, it also gets uploaded over here to our minIO storage. And if we need to use this to back it up, we can actually download it. Now, when you visit Coolify.io, one of the options for hosting is also this cloud option. So let's talk about what that means. So if you take a look at the pricing page, on the basic plan, they talk about it being able to connect to 2 servers, and it's $5 a month. So essentially what you get with Coolify Cloud is a Coolify instance that can manage other VPSs. So when you sign up for this $5 a month management instance, you're not going to be able to deploy applications there. You're just going to be able to manage other VPSs that you potentially have resources running on. And we talked about this at the beginning of the video, the idea that you might want to have Coolify running on a separate instance. So that way, if at any point some of your resources are using a lot of CPU, you can still get to the Coolify dashboard. That's what Coolify Cloud is going to help you with. So I actually signed up over here at app.coolify.io, and I'll show you around. So, I mean, it looks exactly like your main Coolify dashboard, but the only thing is you can't actually create projects directly on this server. Whenever you're creating projects, you need to point them to some remote server. And so I'm going to set that up now. I'm going to point it to the Coolify instance that we've been working on before. So I'm going to go over here to servers and then add my own Coolify instance. Now, I've already set up a private key. I went ahead and added the public key as an authorized key on my server. If you want more info on that, check out the first video in the self-host series. I talk about authorized keys and stuff like that. But let's give it a go. So I'm going to set this up, and now this Coolify hosted instance will be able to manage my apps.gdn server. Let's see. When I click this button, validate server and install Docker engine, it's actually going to remotely connect to that instance and just make sure that it has everything it needs to be able to create resources on it. So let's try it. Cool. So it looks like it's ready to go. I am now going to try to create a project and actually point it to my apps.gdn server. So basically, I'm managing things from app.coolify.io now instead of directly from apps.gdn. So let's do it. I'm going to create a project. And for this, I'm just going to deploy this public repo that is a static website. So I'll throw the git URL in here. We're going to deploy it to the apps.gdn server that we have connected here. Paste in the URL. We're going to make this a static website. And we can set up that instance domain. So if I go back over to servers, now I technically have this set up already on the apps.gdn Coolify instance, but this Coolify instance needs to know about that as well. So if I set up the wildcard domain in the same way, so apps.gdn, then save that. Now, inside of my project, I should be able to set that domain here. So I'm going to set this as banana2.apps.gdn. Save it, and let's give it a try. And now I'm just going to try to visit it. So if we go to banana2.apps.gdn, the application loads. So basically what's happening here is app.coolify.io, the hosted version of Coolify, is managing this remote server and managing the Docker containers on it and the proxy and everything else. And it's able to spin up resources remotely. And so if you get Coolify Cloud in the hosted version, this is basically what you're going to get. You're going to get a dashboard where you can manage things, but you're still going to need some VPS hosted somewhere else that you connect it to, and that's where all of your resources will live. Now, I've done my best to show you how to get things going within Coolify in the best way that I know how, but when you're working with Coolify, you might come across some issues. So first, I want to reiterate that currently, in the last few sections of this tutorial, I've been using the v4 beta 269. So whenever you install Coolify, you might be on a later version, so some things might be slightly different. And I will say, if you do come across issues, there are a few different places you can check out. So if you go to Coolify.io, they have a link to their Discord community. This is probably the most active place where you can get help with your issues. If you check out the Discord, there's quite a few channels. There is the main Coolify channel, but I would actually recommend don't ask for help in the main Coolify channel. There's so many people that just like ask one-off questions and then never get any help in this channel. You want to use the help forum, and this actually is very active. I see people answering questions, including myself, all the time. So if you have a specific question about Coolify, you should open up a post here in the Coolify v4 help forum. Now, also avoid like generalized questions, because I see a lot of people saying, can Coolify run X or can Coolify run Y? Coolify is just based on top of Docker and Docker Compose. So if an app can be run inside of Docker and Docker Compose, it can be run with Coolify. There might be some specific things you have to do to get it working with Coolify, but it is possible. And so ultimately, the answer to that question is yes, but with an asterisk. Like, you ultimately need to figure out, well, how does that going to work in the context of Coolify? So I would avoid asking like simple questions like that. And really, if you want to get something working in Coolify that's based on Docker and Docker Compose, it's going to come down to just some trial and error of kind of figuring those things out. The other thing is, if you come across a real issue, so that is a reproducible issue, and you might even ask about it in the Discord, hey, have you seen this issue before? If it is a reproducible issue and an actual issue that needs to be fixed, you should open an issue over on GitHub. Now, Andras, the maintainer of Coolify, is extremely active. So he's in the comments here. He sees when new issues gets opened. Actually, I'll show you this. Since I've been working on this video, Andras has closed 4 issues that I have opened. And then there was also a couple of PRs that I opened because I wanted to contribute, to give back a little bit. So you can see there's a few PRs that I opened that got closed as well. So Andras is an extremely active maintainer. If you have an issue, open it up here. If you have a feature request, that should happen over on discussions. So any idea for like a new feature or something that you think Coolify should do, don't open an issue, open up a discussion. Technically, you could ask in the Discord first, but discussions are the place where you're supposed to be asking for new features and stuff like that. I'll also say, if you're deciding to contribute to Coolify, there's this channel called Contribute, and you can ask for help in here, or just mention that, hey, I want to work on X feature or Y feature, and do that in this Discord here. I think that's mainly it. I just want you to be aware of the places that you can get help, and you should do your best to ask good questions so that you can get good help. I'll also say that if you come across things, either the Discord or GitHub issues are going to be the best place to get help, because the YouTube comments here, I'll do my best to answer them, but also a week from now, 2 weeks from now, Coolify could be on an even later version, and things could be fundamentally different than from what I've shown you here. So the best place and the most up-to-date place to get help is either the Discord or in GitHub issues. Right now, I'd like to give you my honest opinion about Coolify, because while this has been a Coolify tutorial, at the end of the day, I have been kind of just learning Coolify the past 2 weeks and also just forming my own opinions on it. So here they are. Here's CJ's opinions about Coolify. First question, would I use Coolify for my own server and my own applications? No, the answer is no. And let me tell you why. So Coolify currently is in active development. So Andras, the core maintainer, it's one guy building this app, if you didn't know it. If you look at their GitHub repo, it's literally just him making a bunch of commits. Every now and then someone will make a small contribution, but most of this is just one person trying to make Coolify happen. And that's awesome, but it's also a lot of work. And there's a lot of issues that are coming up and a lot of moving parts. And so just in the past 2 weeks, there have been several different beta versions that I've upgraded to while I've been learning and working with Coolify. And so right now, it's not, in my opinion, it's not stable enough. A lot of people are on older versions, maybe on version 3, or they're sticking to a specific beta version because that version is a bit more stable. But in my experience, I came across a few bugs that were kind of like non-starters, and I couldn't really do the things I wanted to do unless I upgraded to the later beta versions. So that is something to take into account. It's under active development. The thing is, Andras is working hard, though. Like, once the v4 proper drops and all of these bugs are fixed and we're on a less frequent update cycle, I think Coolify will be in a much better spot. The other thing is, I know how to use and have taken the time to learn and understand all of the tools that Coolify is using under the hood, right? Because Coolify, at the end of the day is kind of just like a Docker Compose manager. There's a few more things that I don't want to simplify it that much, but one of the main things Coolify does is manage Docker and Docker Compose containers. And I know how to do that myself from the command line, right? Like I've learned how to use Docker. I know how to use Docker Compose. And so a lot of times I was fighting Coolify to do the things that would be very easy to do if I could just run a Docker Compose file directly. And in a similar idea, Coolify also uses a proxy. So it's either using Caddy or Traffic, depending on which one you choose. And I have spent the time to learn Caddy directly. I've actually done a video on how Caddy works. And so a lot of times I was banging my head against the wall trying to get Coolify to take these Caddy settings that if I was just using Caddy directly, I could have just written the codes to do that. And then same thing, Coolify is using this Caddy Docker proxy under the hood, which actually allows you to add labels to a Docker Compose or to a Docker container, and then Caddy behind the scenes will pick up those labels and add their settings. But when you're using Coolify, it's doing that kind of like indirectly. So ultimately, because I've already spent the time learning and I know how to use these tools like Docker Compose, Caddy, Traffic, and like Caddy Docker proxy, I would prefer to just use those tools directly rather than to have to figure out the Coolify way. Now, I know for a lot of people, that's not the answer they want to hear, right? I mean, people want this to be magic. They want to be able to have a one-click deploy experience just like you have on Vercel. And for a lot of things, you might get that in Coolify, but for a lot of other things and for your own like custom applications, it's just like not really there yet. And I'd rather spend my time doing it directly than actually doing it inside of Coolify. Now, all of that said, I have really high hopes for Coolify. I want to revisit Coolify like maybe a few months from now to see when the stable v4 drops and when a lot of these like little bugs that are kind of like non-starters get fixed. And because I would love to see a self-hosted, truly one-click solution to give us that like Vercel and Netlify and Heroku-like experience. But we're a little ways off from Coolify, I think. I will say, if you check out Syntax episode 730, so this is where they talked about owning your own platform as a service. There were some other services they mentioned, right? So there's like Kubero and Caprover and Doku. I definitely want to give some of these a try as well. And also like Piku. I think Piku works on like really limited resource servers. And if I guess if I'm being honest, this is just the CJ rants and says what's on his mind segment. That's a potential another issue that I have with Coolify is the amount of resources required for it, right? So because Coolify is a PHP Laravel application, if you look under installing and like resources, Coolify alone needs 2 CPUs and 2 gigabytes of memory just to run the Coolify application that manages all of your other applications. If I have a server where I just have Docker and Caddy installed directly, I'm going to be able to do a lot more because I don't have this PHP Laravel application and its associated databases all running on that same server to manage it. But that comes with its pros and cons, right? Like if I'm managing a server with Caddy and Docker directly, I'm doing all of that from the command line, where as with Coolify, you get like a nice little dashboard. I don't know, but those are my thoughts. I will say Coolify doesn't exactly deliver on the promise of just like magic one-click deploys, especially if you're trying to deploy your own custom application code. I will say the like the one-click deploys for like Supabase and a lot of the other built-in apps to Coolify, those work really well. And so if you want to be able to deploy apps that way, completely fine. But for me, if I'm deploying my own custom applications, I'm going to have to customize my Docker in my Docker Compose at the end of the day anyways. So I don't really see the benefit in using Coolify. So that's it for this video. Thank you so much for watching, and thank you for tuning in for this self-hosting series that started about a month ago. And for all of your kind comments and encouragement, because it's definitely been the motivation to keep going and creating this kind of content. So let me know in the comments, what do you want to see next? What are you interested in? And I'd love to cover it. I'd love to talk about it. So yeah, that's it. See you in the next one.